welcome back to the SciMax channel. I talked about litGPT or litdb with OpenAlex and GPT yesterday for the scientific literature, and if you notice, there was all these local extensions for PDFs, PyNotebooks, HTML, Markdown, PowerPoint, etc. So today I want to show you that we can also use litdb for local files and we can search for them. You can use it for both the scientific literature and your local files. So if you have documents you've written, proposals, Jupyter notebooks for your electronic lab notebook, etc., then litdb is a gateway into being able to search them. So let's start out here in the terminal. I'm still going to focus on that for now. So I have a directory here, and there's some files in it. So the first thing I should do is initialize a litdb here. So this is going to be a new one, and this will generate the database and create it for me. As before, you have to give yourself, put in your email address. We don't need an OpenAlex API key for this. And now we can type litdb about, and it'll show us a little bit of information about the database. So this is where it's located. We have 0 sources because I haven't put anything in it. So again, looking at files, we can add some of these files. So let's just do one of them, litdb add files, meanwhile. This is going to take that file, turn it into a text using some library, and index it. And then now if we look at our database, again, we should have one item in it. Right, and we can now do a vector search. So before we do that, let's have a look over here. I think meanwhile is just a 1-sentence Word document. Meanwhile, it was sunny in Jamaica. So let's do litdb vsearch and say clear skies. This should, there's only one thing to find, so it should find it. And there it is. That's the text that was in there, and it's pretty close. We can also index that directory. So if I say litdb index files, that will go and add all of those files, the PDFs, the HTML, the meanwhile, etc. This LLM Science Review is a fairly long review article written by Andrew White. It's kind of interesting about large language models in science. It makes 79 chunks. We use a document embedding for that. And this is a scientific article that I wrote. So now let's do the vector search again and see what comes up. Now we have six articles. And the top one is, this one here. The second one is, it was a gray, stormy day. That's the content of that PowerPoint file. And then the third one's kind of far away. It is the CMU HTML file. This is just information, about the department. Some of these people, like Neil, work on clouds and things like that. And so it's hard to say what in here matched it. Here's the Royal Meteorological Society. And so probably that should be like the third closest semantically. And then if we look at our database again, litdb about, it should list 6 sources, and it's still very small because these are all quite small databases. Let's do litdb GPT, tell me about data sharing strategies. Hopefully this runs a little bit faster. I'm using a Mac M2, which is quite a bit faster than the machine I have at home that ended up being so slow I made it stop. So this is using Ollama and the Llama 2 engine. It embeds that prompt into a vector, does rag to find the top 3 documents, and then it feeds those as context to Llama 2 to respond to this question here. Now, one of the papers that is in here is, I guess I can just open it, it's examples of effective data sharing. And so this text is stored in the database and should get used by the Llama 2 model to generate a response. In general, I haven't been a real big fan of using the GPT feature because it seems so slow. But this is the text that was generated from that paper. It's generated by PyMu-PDF for LLM. So that's kind of long, but here is the prompt. So data sharing, it refers to this. It has some, information that is used here, and then this is the top journal that was used. So let's scroll through here. Here is a DOI. Let's, just for fun, add that. And now we're going to have a database that can find things in my local files and in internet files. So let's see what that one actually is. So this one is looking at bulk composition dependent absorption energies. For the paper. All right, so that still finds the CMU one as a reasonable one. We can do something, if you don't want to see all of this text all the time, most of these commands should accept a format option, and the format is going to be a Jinja template. So we might do something like this, and I'm not a super, I think if I say I just want to say first 100 characters, I think we can try it like that. So source and text are variables that should be available, and so that's what we get here. You get the source. Oh, it has a /n. I thought that would be a line return. Maybe if we try it like this. Then you can fine-tune what comes out a little bit. We can, let's see, I showed you the index. If we add a new paper, a new document in here, let's do, save that in there, and then close that. And then we can also do litdb reindex files. And that should only pick up the new one. Maybe we just do reindex. Anytime you run the index command, it saves the path to the directory, and so we can just reindex everything we've ever indexed before. So now it's done that, and we can do full text for snowing, and it should find just the one article. So there it finds the one article. If we do vsearch weather types, let's see what comes up. There should be 3 files that have weatherish stuff, and so it does find those 3. The snowing, the sunny, the stormy. That's the whole point of the vector search, is to find things that are nearby and close. So that's sort of the main idea that I had for doing local search. We can index all of these kinds of files. I can show you one more thing. We can also do a URL. So let's go to back up here. Let's look at this one. So here you might choose to do this. So this is the actual URL. So you can add a DOI, but I'm just going to add the URL here to see what happens. Litdb add like this. And that's going to pull the HTML from that page and then index the HTML and store it in the database. So if I say litdb, let's just do a full text on alkyl. Then it finds that, it finds it in there. Did I miss something? Impact of alkyl. Oh, there it is. Right here. So it does find that. It's kind of curious. It has it listed with this source. That doesn't seem right. So there may be a bug on that. I may have to work out something there. Okay, so maybe hold off on adding URLs until that gets resolved. But otherwise, the main point here is it's pretty easy to index your PDFs, index your files, index your Jupyter notebooks, and then you should be able to search it. So that's all for now. I will end here so I can try to fix the reason why this looks like it's in the wrong place. And by the time you get to try it, that should be fixed. Thanks for coming. Come back next time for